Homework. That was funny. Right. Stop. Stop. What do we get for this? What's our answer? Regression of price versus rooms. What does the interval rooms tell you about the effect of rooms on price? And this confidence interval just means it's different from 0. Or there's going to be something.
Values here. This is a classic case of multicollinearity, even though rooms look like it was going to be a fantastic predictor. Well, rooms isn't the predictor, but when you look at it in terms of the whole regression. What does the 95% tell you about rooms on price for the entire population? So number of rooms has a significant relationship with the sale price. Part C then.
P-value less than 0.05. So rooms at number room. So
Is to run multiple regression with all the variables and take a look at the coefficients after you do that.
multiple regression. Multiple regression. Multiple regression. Multiple regression. This one. Multiple Mul- mul- multiple regression is a multiple regression. Therefore, we
So, see, book
what up?
or your worksheet. This
What are you
is all
doing?
our variables C, D, E, and F.
Why'd you do that?
All our variables are,
Why'd you do that? Why'd you do that?
and opening up regression again. Are like,
No idea what's going on here.
so once we run our
P-value for rooms is now at 0.72. And looks like we should be getting correct numbers. So, what is we look at? What are we looking at? Okay, for rooms, well, it's obviously 0 is contained. P-value for rooms is 0.72. P-value for rooms is 0.72 more than 0.05, which is more than 0.05. So, what is the question again? Why is it different from B? Why? Tell me why.
regression, we look at our p-values for our predictor variables, and we see that all of them are significant except rooms. So rooms went from a very, very small p-value to having a very large p-value, and it's because of multi-covalent. Okay, so on this sheet here, this is a classic case of multi-covalent. Simple regression model is believable. The coefficient of the rooms is between well, it doesn't matter what the confidence interval is. I hate that this book focuses on confidence intervals. The p-value is very small, so it's a significant predictor. However, in the multiple regression model, rooms and the other three variables have multicollinearity occurring, and so we see that the regression, multiple regression ends up having rooms not be a significant predictor. So again, why is that? It's due to multicollinearity, which is basically saying redundancy. These variables input the same type of information, right? Smaller homes have fewer number of rooms usually.
Okay. You know what? Oh my gosh, that's so much words. I don't feel like um 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 the reason for this this difference from the simple regression. For the single is that there is multicollinearity. The number of rooms is highly correlated with the size of the house. So this results in redundancy. Multiple regression, I guess. I don't know. Can I please be done with that problem now?
Moving on. Probably have 2 bucks.
Yay! How many more questions left? Right, 1, 2, 3, 4, 5. 5 more questions. 5 more. Dude, what the heck? Why are they asking you that question there if they haven't even covered multicollinearity yet? The heck? Wait. Number 19. Stop, 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 stop. Stop, 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 stop. Stop. 19. Oh. 1027. For number 11, 19. Oh yay, now we're gonna actually get the dummy variable thingy again. So hopefully I did that right the first time. But if I didn't, I'm probably not even gonna fix it because she might still give me 100% anyways. Because I think she just gives you 100% as long as you did the assignment. Oh man. Estimate an appropriate multiple regression model to predict the number of worker hours needed to erect given boiler drums. Using all the available explanatory variables, which explanatory variables should be included in the final version of this regression model? Justify your choices. Okay, well, let's see how she does the dummy variable thing. That's going to be the big key here. Hopefully it's the same way I did it before. We still have 5 more questions to get through. Although, yay, it's only 5 more questions, but still. Oh, that was funny. How is it already 4 o'clock? How on earth has it taken me this long? What on earth? What? Dude, it's taken me 4 hours, well, not including eating lunch, to eat lunch and then get this far. Or to do the last 2 questions from the last assignment, and then do the first 4 questions from this assignment. Is taking me 4 hours. Are you kidding me? I thought it was like 2 o'clock. I thought it was like 2 o'clock, and then I looked at the time. It's 4:04. Dang it. Well, that was fun. My cube sucks. Time to do. Now, number 19 should just be the same old thing I've been doing this whole time, but with the dummy variable, so hopefully I do that right. Hopefully. Stop.
Boiler drums.
Let's see. This equation includes the 2 original quantitative explanatory variables plus dummies for industrial boiler type and steam drum type. All variables are easily significant. Interpretation of the coefficients is industrial boilers increase average workers by this much over utility, and the steam drums increase by this much over mud drums. Yeah, so how were you supposed to know that you were supposed to do the industrial one instead of the steam one first? The last time, that's like I said that the utility is less, increases it by this much compared to the utility ones. So I did it backwards from that. But I mean, how are you supposed to know which one's increased and which one's decreased? Well, you could just switch it after the fact, but yeah. This is the exact same type of thing as before. The exact same thing. This is like a repeat of the last question from the last chapter. Like, what's the difference here? Like the only difference is that we're looking at the p-value. That's literally the only difference. They didn't even ask about trying to test the assumption, if the assumptions are held up. Stop. Which one should be included in the final variable? Yeah, like that's so simple. It's the same thing as before. But I'll just double check here.
In future projects. Consequently, data from 36 randomly selected boilers were collected in addition to worker hours Y. The variables measured included boiler capacity, boiler design pressure, boiler type, and drum type. All of these variables in this file. Estimate an appropriate multiple regression model. Justify your choices. Which explanatory variables should be included in the final version of this file. Okay, so the first thing, if you're looking at the original data file, is the boiler type and drum type are categorical variables, and they're in words, so we need to translate that into a dummy variable where we use 1 to represent the condition that is the title of the variable, and 0 to represent no. So 1 is yes, 0 is no. So here I just pick one of the 2 types of boilers. In this case, it's the utility. I chose industrial. Could have chosen utility, doesn't matter. So I call my variable industrial, and then I use the equation if G2 is equal to quote industrial, comma 1, comma 0. We'll quote in 0 everywhere you see utility, and 1 everywhere. And then I did the same thing. I just picked one of the types of drum heads, steam, that happened to be, and so then I quoted it.
Yay! Time to do this again. This is the exact same problem as before, except for one tiny little change. That's the only thing. Stoppy. Industrial steam, and then equals if this equals industrial 1 comma 0, and then if this equals steam 1 comma 0, and then go down and there. So done with that.
2 equal quote steam, comma 1, comma 0, and we see that every time you see mud, it's a 0, and every time you see steam, there's a 1. So that's a dummy variable. I'm sorry I didn't get to explain that in chapter 10, but it works the same way. There's a little bit more
Why did you select residual and line fit plots? Why would you select those? Maybe why? Why would you do that? I thought that only works for single or simple regression or something. Like why? What? Is that necessary? I don't think so. I thought that only works for multiple single.
So a couple of things that jump out, looking at the normal probability plot, we see that there's definitely a curve to
data analysis. Compare the worker hours. do all of these. Do, 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 do. Oh my goodness. I don't know why I'm doing this. It's because the professor did that in her thingamajiggamajag. Oh man. Oh my goodness. Oh man. Predicted versus residuals versus predicted values. So we have that and this. Oh, I forgot to do the thing. Oh man. No. How did this mess up? How? How it should not have messed up. There. So we have outlier. Okay, interpretation of dummies. Industrial increase average worker hours by this over this. Steam drums increase average worker hours by that over my drums. That's the same thing I did last time. Okay then. So what's the question asking? I'm not going to type anything I don't need to type. Include all variables because p values are less than 0.65. Boiler capacity, all those, and dang it, I'm just gonna dang it. Industrial boilers increase average worker hours. Three, four, 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 and steam. Dang it. Over utility boilers. Steam drums increase average. Steam drums increase average worker hours by 2,093 over mud drums. There, that's all I need. That's it. That's the entirety of what I need.
There's some sort of violation of normality. Looking at my predicted values versus residuals, I don't really see a pattern to violate homoscedasticity or linearity, but there's definitely a value that's sticking way out here that's an outlier. Again, rather than having done the straight residuals, if this was the standardized residuals, we'd probably see
Did we look at standardized residuals? Yeah. Most of them are all within 3 and -3, but we have one that's outside. Oh no! I just skipped. Oh, now. How far did I skip? Come on! Stop!
For each unit of increase of boiler over the interpretation of the coefficient.
Dude, how far did I just skip? Come on. No.
Way out here that's an outlier. All right, please for each of the code that see that this outlier is above +3. Okay. All right, so then looking at my coefficients and the p-values for each, it's the dummy variables for industrial. Those p-values are very small. There's one industrial worker hours. Okay, so that's what those two coefficients down there mean. Obviously, boiler capacity and design pressure for each unit of increase in boiler capacity, we see a 0.0087 increase in worker hours, and for each one increment unit increase in design pressure, we see 1.926 or 1.93 increase in worker hours. So that's how you interpret the
Oh, jeez. Is that it for number 19? We have 4 left. 4 more problems. 36, 44, 51, and 52. 36. It's probably going to be at the end. Thirty-six. Stop. 36. 36. Where's 36? Come on. Oh, found it. So, 36. Estimate the regression, and you expect predictions of sales in future years to be accurate if they're based on this regression equation. Right. I mean, this should be pretty easy. Just don't know about this question right here. So it's going to be for 1023. Whew, for a second I thought I was missing. This is for 1136. That was funny. So it should be pretty easy. So, yeah, it looks like.
And I'm going to need to get prepped for my next meeting. So, and that actually divides it up. We'll have 4 left to take it up. I'll jump back on this afternoon sometime.
Only 4 left, and then we're finally done with today's work. And then we have tomorrow's work, and then we have Monday, and then we have Tuesday, and then we have Wednesday. I have to do stuff all the way every single day for the next 4 days. This is just great. This is just wonderful. Come on. Come on. Come on.
All right. Good evening. I just need to wrap up the last
It better not.
from lesson 4.2, and the first one that we're going to look at is problem 36 from chapter 11. The owner of a restaurant in
Thank goodness. Right, so they just did their analysis of all those. Population advertising, previous advertising. Yeah, it's the same. We did this problem already. Oh my gosh. Now the prediction in year 20 is going to be interesting. And what about this? Standard error is this. R square is high. Coefficients are significant. So those are the reasons. All the same things we've been looking at this whole time. Oh my goodness. Oh man. So we're just going to do our multiple regression again, right?
advertising predictions of sales in future years. So I think I should put on the data tab. So you see we have sales data for the 19 years, population advertising. So to get the regression output, go to the data analysis toolpack, open up the regression option, click on OK. Our input for Y is the sales data. This here, the sheet. They're not asking us about any of the regression assumptions, but again, I tend to think it's easier to have them checked off, and you can look at them in case they do ask about it. All right. So that's that.
Multiple regression. Stop. Stop. So there we go. And then we are getting 2.31. Getting 2.31. No, 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 no! You've got to be kidding me. Why? Why would you do that? Is this going to happen every time You've got to be kidding me. Please don't tell me this is going to happen every time I switch between windows. Please. It's using a different player, which is terrible.
All right. Savings of that. There we go. All right. So those are all our output. Again, we would not need the residuals of the plots. So, looking at my answer sheet here, the main thing that they were wanting to know was how good the model fit. R squared. It's indicating that 98.7% of variability in sales is accounted for by a regression model, and with a Pearson correlation coefficient of 0.99, excuse me, that's a very, very strong relationship, almost a perfect relationship. So that's awesome. The model itself is significant because the p-value here is 2.31 times 10 14, so very small p-value. Looking at all our predictor variables, our regression coefficients are all significant predictors. Can you expect predictions of sales in future years to be very accurate if they're based on this regression equation? Yes, given the very strong relationship, a very good fit of the data, and then a fairly small standard error, there should be no reason to believe that it would have problems with the future predictions. So then, given that, basically.
I'm going to copy the words. Yay! Yay! Hold on a sec. Can I fit all this stuff in the top? How many rows does she have here? You've got to be kidding me! This is... Oh, God! No! No! Why? Why? Every time you make it full screen, it just automatically restarts. Are you kidding me? Every time? Come on. Come on. There's gotta be some way to fix this. I don't think there is. I think I just have to literally memorize where I am in the video every time I switch windows. But I was going to copy all the text.
Good evening.
Or I could just keep it not full screen and then it wouldn't have that problem, I'm assuming. The R square is very high. How many rows was this lower part? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Oh, it's not going to fit up here, is it? Dang it. I could move everything down one so it fits. No, I'll just put it below. I'll just put it below. I'll just stop. 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 Stop saying stop. Stop saying stop saying stop. Stop. R squared is very high. The standard error of estimate is only about 340. And the coefficients are all significant. They're all significant, so there's no reason to believe that there's no reason to believe that that future predictions will not be fairly accurate. Now we have to do the little thingy that they're doing down there. What are they doing? It says predict sales in the next year, year 20. How do we predict it? We believe that the population, we'll assume that the population is the same. Why don't you just increase the population? Because it seems to be increasing every single year. Well, I don't know. Not quite every year. Maybe just take the trend of where the population would be based on the previous population. But anyway, it's just apparently assume no change from year 19. Planned advertising level is 30,000, and that means, and you already have your previous year's advertising, so because the previous advertising is just the previous year's. Like this number is this, this is this, this is this, this is this. So it's pretty simple. Find a prediction and 95% prediction interval for your sales in the year 20. I don't want to make it full screen because it's going to mess up again.
I just need to wrap up the last problems from lesson
What?
14, so very small p-value times 10. The model itself is for all our predictors. Can you expect predictions of sales in future years to be very, very accurate? To a very good fit, should be no reason to believe that you would have problems with your future predictions. Right? So then given that, they say, let's predict in year 20 what would be the sales if the population doesn't change, if in year 30, $30,000 is put in for advertising, and the previous year's advertising is 28,000. Okay, so the population of 121,069. If we go back to the data, that is the last data point here for year 19, right? And year 19's advertising expenditure was $28,000. So going back over here, that's where I got those from that other sheet. Right? And this one I just typed in 30,000. All right. So we know that we can make the prediction by using the regression equation where we use the intercept plus.
Looks like I can actually put the answer to the problem up here because she made too many unnecessary columns or rows. That was funny. So I could just do it over here. So we'll go with, or here. So we'll just do this, and then we can fit it over here. Or we could do it, in fact, here instead. I don't know. Should fit here, right? We can get the answer of sales 2020, year 20 sales, year 20 sales. So the equation is going to be equal to this one plus population times given population is the same as last year, so it's going to be this plus you know what? I'm just going to do this. Man. 121,069 plus maybe it would have been easier to type all this stuff. Wow. That was funny. Advertising times, what's the given? 30,000. plus previous times previous years added. I mean, that's got to be it, right? That's it. We're done. We got 18 something or other. So we got 18, 6, 24, 51. Oh, yeah. 18, 6, 24. Oh, my gosh.
The coefficient plus or the $124.
18, 6, 24, 51. Then we get, oh man, how do we get the confidence interval? How?
Get the wrong sense. So the prediction interval is similar to a confidence interval. The main difference is that when you go to calculate t-value, you're going to use n minus 2 for your degrees of freedom. So n minus 2 instead of 1. So we have 19 observations, so that's why in the equation here I have 17. And use the t.inv.2t, that's divided p-value to 2 tails, right? And 0.025 is each of those tails in order to add up to be 0.05. So that's where I get that next value, and then the degrees of freedom of 17. So my
t-value is, I hate that I can't go into full screen anymore. t.inv.2t parenthetical. That was 0.025 comma 17 because of 2 minus 2 or something like that. Wow. Oh my goodness. Oh my good. $2.4581. Oh,
t-value 0.245.
at standard
the standard error 341 is just copied from cell B.
okay. Equals this. Boom. Stop. And then we are going to do the thingy. How do we do it?
7 up here in my output, right? Standard error SE. So now I can bring all of that together for my prediction interval, where I have my upper limit being equal to
This
mean
number
23 plus the t-value times SE.
plus t-value times SE
And
minus t-value times SE. Stop. 95% prediction interval. 95% prediction interval. So, lower, upper limit. I don't know why we do upper limit and lower limit. I prefer lower limit and then upper limit. Because whenever we read, most of the time we read numbers from lowest to highest number. So you would start with the lower number, go to the highest number, stop. Equals this plus this times this equals, I'm an idiot. I did the upper limit first. Equals this minus this times this And we got 17,786, 19,462. So there's that, and that's got to be done now, right?
Then is equal to the predicted value, the average predicted value, minus the t-value times the standard. So we can basically say that the store manager or owner can be 95% confident that the true predicted value for sales in the following year is between $17,786.19 and the upper limit of $19,462.82. Again, given that the population stays the same and they do invest $30,000 for advertising. All right, so that was number 36. The next one is number 44.
Well, we're done with 36. Wow. Wow. Stop. Oh my gosh. Oh my goodness. Oh my goodness. Oh man. Stop. Oh, that was funny. Stop. We only have 3 more problems. 3. How long can it possibly take to do 3 problems? Number. What? That was funny. Number 44. A through E. A through E. That was funny. A through E. A through E. That was funny. Oh. Stop. A through E. Test. 1, 2, 3. Stop. Number 43. Number 43. 44. Wait. 44. Let's see. Look at the matrix of correlations. Correlation matrix, run regression, and equation. And thankfully, we don't have to do F. Thank goodness. Thank goodness. We don't have to do F. Yes. Okay, so I think we should be fine. And Bye.